In this video, we are going to talk about operations and composition of functions. So first, if you have not completed this warm-up, please pause the video now and give this warm-up a try, and then we'll go over it. So first in 1a, we're doing 3 times f of negative 3. So I'm going to put negative 3 into the x of f, and I'm going to get negative 11. So I'm doing the 3 times the negative 11 to get negative 33. F of 2, so I'm going to plug 2 into f, which is going to give me 9, and then I'm going to do 9 plus 1 is going to give me 10. Now this is a little bit trickier. We're going to plug x plus 1 into x. So instead of x, it's going to be x plus 1 minus 4. So now again, this is the whole f function. So f of x plus 1 is 4 times x plus 1 plus 1 minus 4. We're going to distribute, then combine like terms. I'll be left with 4x plus 1. We'll do the same thing with the g function on this side. So I'm going to do negative 5 times whatever g of negative 1 is. So it means I'm plugging negative 1 into g to get 8. So negative 5 times 8 is negative 40. We're going to plug negative 3x in now for x. So in the x spot, we're going to plug in negative 3x. And then this minus 2 is going to go on the end. Multiply and combine like terms. And we'll be left with a 6x plus 4. Again, this lesson's a little bit tricky. We're going to put 3x plus 1 in for x. So 6 minus 2 times 3x plus 1 minus 7. Distribute 6 minus 6x minus 2. Again, you're distributing a negative 2, so be careful there. Now we're going to combine like terms. 6 minus 2 is 4 minus 7 is negative 3. All right, now on to our notes. We're going to talk about different operations when it comes to functions. So first we're going to talk about sum. So one way you're going to see sum of functions is this combined writing where it's f plus g of x. This is the same as f of x plus g of x. And I'm always going to split it right away. Same with subtraction, f minus g of x is the same as f of x minus g of x. All right, so we're going to do f plus g of 5. So we're really doing f of 5 plus g of 5. So that means I'm going to plug 5 into my f function. Sorry, guys. 5 is going to go into my f function. So here's f. I'm replacing every x I see with 5. So we're going to have 5 squared minus 3 times 5 plus 1. I can type that in my calculator, which would be 5 squared minus 3 times 5 plus 1. It's going to give me 11. So 11 plus, now I'm going to do the same thing with g of 5. I'm going to plug 5 in for g, and I'm going to get 25. So my final answer would be 36. Now we could also just do f of x plus g of x. This just means we're going to add the two functions together. So f of x, like we said, is x squared minus 3x plus 1, and we're going to add that to g of x, which is 4x plus 5. And now when we're adding these, remember we're going to add like terms. So x squared doesn't add with anything, so we'll just bring him over. Then we have negative 3 plus 4 gives me 1x, or just x. And then 1 plus 5 gives me 6. Now we do the same thing with subtraction here. So I have f of negative 3 minus g of negative 3. So I'm going to do f of negative 3 first. So everywhere where I see an x in f, I'm going to replace it with negative 3. Plug that in my calculator. And I'm going to get 19. Then I'm going to do the same thing with g. So in G, and everywhere where I see an X, I'm going to replace it with negative 3. And I'm going to get negative 7. So I'm minusing a negative 7, so really I'm adding, so I'm going to get 26. So be careful. Remember, from the beginning part of the problem, we were subtracting these two functions. That's where this subtraction sign is coming from. We can also do this with just the function. So I can do f of x minus g of x. And now this can be fairly similar to what we did above. So x squared minus 3x plus 1 minus 4x plus 5. Now we can just subtract the like terms. I always like to distribute this negative in. So x squared minus 3x plus 1 minus 4x minus 5. I just think it makes it easier to combine like terms. So the x squared gets brought over. Negative 3 and negative 4 is negative 7. 1 and negative 5 gives me negative 4. Now we're going to do the same thing with product. So f times g of x is the same as f of x times g of x. So I'm always going to split it. So I'm really doing f of negative 4 times g of negative 4. So again, first I'm going to plug negative 4 into f. So negative 4 squared minus 3 times negative 4 plus 1. Notice I'm always using parentheses. That's super important. Now we're going to plug that in the calculator. And I'm going to get 29. So 29 times, now we're going to work on what g of negative 4 is. So I'm going to put negative 4 into g. Negative 4 times, 4 times negative 4 plus 5 gives me negative 11. So we're doing 29 times negative 11 to get negative 319. Now we can also just multiply functions. So I'm going to do f of x times g of x. And now when we have something like this, we're going to distribute. So remember when we multiply, our exponents grow. So first I'm going to do this x squared times 4x, and I'm going to get 4x to the third, because I have 2 x's here and another x here. So that means I have 3 x's total. Now I'm going to do 4x times 5, which is 5x squared. Now I'm going to do this negative 3x times that 4x. It'll give me negative 12x squared. Again, I have an x here and an x here. That's why I have 2 of them. And then negative 3x times 5 is negative 15x. Now I have this positive 1 times each of these as well, so plus 4x plus 5. Now I'm going to combine like terms. So 4x a third does not combine with anything, but 5x squared and negative 12x squared combine to negative 7x squared. Again, when we add, the exponents stay the same. So when we multiply, our exponents are going to grow. When we add or subtract, our exponents are going to stay the same. Keep that in mind. Negative 15x and 4x is negative 11x, and then plus 5 at the end. Now we're going to talk about composition of functions. So when we have an open circle like this, that means composition of functions, versus a closed circle means multiplication. So make sure we can distinguish between those two. So that means that the g function is going inside the f function. So my g function is inside my f function. So whatever function is second is the function that's going to go inside the first function. So I'm going to rewrite this as 3 is going into g, and then that answer is going into f. So first I'm going to find g of 3, which means I'm going to take my g function and I'm going to plug in 3 for x, and that's going to give me 8. Now, since I'm doing f of g of 3, that means I'm taking the answer to g of 3, which we said was 8, and now I'm going to put it into f. So now I'm finding f of 8. And so f of 8 is going to be 2 times 8 plus 3, which will give me 19. So we're going to do a couple practice of each of those. So now here's the other notation. So again, we're always going to work from the inside out. So the first thing I'm going to do is find f of 2. So f of 2 is when I put 2 in for the x in f. So 2 times 2 is 4 plus 3 is 7. Now I'm going to take that 7 and I'm going to put it in for g. So I'm going to do g of 7, which would be 3 times 7 minus 1, which would be 20. And that's my final answer. Let's do a couple more with some more complicated equations. So again, always work from the inside out. So I'm going to do g of 2 first. So the first thing I'm going to do is take g and put 2 in everywhere where I see an x. And so g of 2 would equal 4 plus 4 is 8 plus 3 is 11. Now I'm going to take that 11 and I'm going to put it into f. So I'm going to do f of 11, which means I'm going to do 11 minus 5. So that means my final answer is 6. Now here we have our other notation. So first I'm going to put 7 into f. So 7 into f would be 2 times 7 plus 3. So f of 7 would equal 2 times 7 plus 3, which would be 17. Then I'm going to take that answer, 17, and put it in for g. So I'm going to do g of 17 would be 17 squared plus 2 times 17 plus 3. And I'm going to type that in my calculator because those are going to be some big numbers. So 17 squared plus 2 times 17 plus 3. 326. That's going to be my final answer here. And this will end our operations. If you have any questions, please ask.